Hey guys, so today we're going to be starting day 3 of Ace the Algebra Star, and we're going to first look at key features of a linear function. So a linear function is a graph of a line, and there's just a few key features that we need to focus on. The first one that we're going to look at is the y-intercept, and this is where the line crosses the y-axis. For the most part, it is an easy point to see on our graphs. For this particular graph, our y-intercept is at 0, 4. Alright, the second point that we're going to be looking at is our x-intercept, or our 0. This is where the line is going to cross the x-axis. For this particular point, we're at -2, 0. And the slope is what determines the steepness of our graph. So in order to find the slope, what I like to do, of course, first is make a table. So when I make a table, I have my x and y values. My first point, we have -2, 0, and then 0, 4. So once I have my table, again, this is just to help organize your data. We're going to take this and plug it into stat edit. So stat edit comes next. And we're going to get our calculators and go to stat edit. So if there's anything typed in your calculator, the easiest way to clear out to clear out your columns is highlight the title, clear, enter. Again, highlight the title, clear, enter. And I'm going to type in the numbers -2, 0, and then 0, 4. And to find the slope of this graph, we're going to go stat, calc, number 4, and press enter 5 times. And this is going to give us our A and B value. Of course, our slope is always the A value in our graph, and A for this set of numbers is 2. So that is our slope. Let's look at key features of a quadratic function, and we just got done going over this in our quadratics unit. And there is a bunch more key features in this one compared to the last one. So the first one that I want to go over is going to be our x-intercepts. These are the same as our zeros, roots, and solutions. And again, this is where the graph crosses the x-axis. If we don't cross the x-axis, then there is no solution. The second key feature that I want to talk about, of course, is the y-intercept. And again, this is where the line crosses the y-axis. Third point is our vertex. This is also called our maximum or minimum. And lastly, that invisible line that cuts our graph in half, that is called our axis of symmetry. And we can see this written as an equation for this graph. our axis of symmetry is at x equals 2. So that would be all of the key features for this graph. The next thing we want to talk about is domain and range. So there are multiple ways that we can see domain and range. We can see it expressed as a list of numbers, and this is called discrete. And we can also see this as a graph or continuous function. So we have discrete and continuous functions. We will always write continuous functions as using inequality symbols. Discrete functions will always be written as a list of numbers. So we're going to first look at the left column. And let's start by writing the domain from a list of numbers. So your domain is always going to be your x values, range is always y. So all of my x values in this particular problem, again, we want them in order. So in order from least to greatest. You always want to go from the smallest number to the biggest number. So my smallest x value, if we look at this list of numbers, is -3. Then we have 2. We have 5. And I see 2 7s, but we only have to write this once. So another point, only write each number one time. So we're only writing each number one time. So if we go back and we're going to write our range, again going from least to greatest, our smallest y value is going to be -7. And then I see -4, -3, -1, and 0. This list is longer for our range because none of the numbers repeated. Okay, let's go ahead and look at the mapping. So mapping, this one's pretty easy. Again, we're going to write them from least to greatest. So we have -9, -8, -7, and -6. Our range, we have -2, 0, 8, and 9. None of these numbers repeated, so both lists are the same size. Okay. For the next problem, we're looking at a table of values. So again, I want to write them in order from least to greatest. So I have 1. We have 3, 5, 6, 9, and 10. And for our range, we have 2, 4, 6, 7, and 9. Alright, and when we're looking at a graph, so domain again is x. I'm going to work from left to right. So that way, if I'm working from left to right, my numbers are automatically going from smallest to largest. So our domain, we have -2, 0, 5, and 7. For the range, I'm going to work from bottom to top. So my range is going to be 0, 1, 4, and 6. Again, I worked from bottom to top. And that would be how we would write a list of numbers given a discrete function. So let's take a look at our graphs whenever we have a continuous function. So for these, we want to see a line on our graph. And again, we're going to be using inequalities. Keep in mind that whenever I have an open circle, so an open circle, this represents less than or greater than. A closed circle, so the one that's filled in, this represents less than, equal to, or greater than or equal to, depending on the graph. So let's go ahead and look at our first graph. We have a line. I see an open circle. I see a closed circle. So an open circle is going to be less than, closed circle, less than, equal to. So I'm going to start at my smallest value, which is at the open circle. So my smallest value on the x-axis, this is at negative 1, 2, 3, 4, 5. So negative 5 is my smallest x value. It's going to be less than x. And my biggest x value, this is at positive 1, 2, 3, 4, 5, 6. So less than or equal to 6. And then for my y values, I'm going to work from bottom to top. So my smallest y value, that is at negative 1, 2, 3, 4, 5, 6. So our smallest y value is at negative 6, less than y. And our biggest y value is at positive 2. So less than or equal to 2. Again, I'm always going to work from smallest to largest. For the next graph, again focusing on the x's first, I see that I have one arrow. I have one arrow right here. This will affect how we write our graph. It is going in the positive direction, so that means all of my values are going to be greater than or equal to. So here's how we would write our domain. So my x value, I'm looking at all of the numbers greater than negative 2. So that means x is greater than or equal to negative 2. And then my smallest y value is right here, negative 1, 2, 3, 4, 5. So this means that all of my y values are greater than or equal to negative 5. Alright, and for the last one, I see that I have two arrows pointing upward. This means that our domain is all real numbers. Similar to when we were talking about parabolas in the last unit, if your two arrows are pointing upward or downward, that means domain is all real numbers. This lets us know that our y value has a maximum or a minimum value. So I have a minimum value at negative 3, and my arrows are pointing up. So this means all of my y's are going to be greater than or equal to negative 3. And that is domain and range in a nutshell. If you have any questions, please let your teacher know. ask to be signed up for a fair time, etc. Um, with that being said, I hope to see you all in the next